So good day everyone. So today we will talk about telecommunication, the internet and the wireless technology. So in this topic, what you need to know are telecommunications and networking in today's business world, telecommunication networks, the global internet and wireless revolution. Networking in today's business world. So today, nowadays, the speed and scope of the transformation of our communication environment by internet and wireless communication becomes more powerful and extensive as we use this as an important tools in our daily life, such as to communicate our colleagues in social media platforms, to run a business, and even for entertainment and recreational purpose. If you run or work in a business, you can't do without networks. You need to communicate rapidly with your customers, suppliers, and employees. Today, however, you and your employees uses computers, emails, and messaging, the internet, cell phones, and mobile computers connected to wireless networks for this purpose. Networking and the internet are now nearly synonymous with doing business. The diagram shows how information system plays vital and powerful capabilities, opportunities in order to address business challenges. For example, business challenges, inefficient manual processes, large production environment, and growing demand. So the management, organization, technologies select proper information system in order to track components in real time, optimize transportation, expedite communication in order to provide business solutions such as to increase efficiency, lower cost in order to address business challenges. Networking and communication trends. Number one, telephone networks historically handled voice communication and computer networks handled data traffic only. Then, telephone and computers networks are converging into a single digital networks using shared internet-based standards and equipment. Internet of Things will explode as connectivity becomes more extensive. Both voice and data communication networks have also become more powerful, faster, more portable, smaller, and mobile, and less expensive. Networks will be necessary in getting everything to work together efficiently. So, what is a computer network? If you had to connect the computers for two or more employees together in the same office, you need a computer network. Exactly, what is a network? It is a simplest form. A network consists of two or more connected computers. Each computers on the networks contains a network interface device to link the computers to the network. So here is the example of components of a simple computer networks. First, we have a computer, network operating system or server computer, cable, wiring connecting to the devices, switches, and routers. Computer network, network operating system or server computer, routes and manage communication on the networks, and coordinates network resource. It can reside on every computer in the net server. Computer is a serving up web page storing data and storing the network's operating system and hence controlling the network. Hubs and switches. Hubs are very simple devices that connect networks components, sending a packet of data to all other connected devices. A switch has more intelligence than hub and can filter and forward data to a specific destination on the networks. Then routers. A router is a communication processor used to route packets of data through different networks, ensuring that the data sent gets to the correct address. So, networks in a large companies. So today, corporate network infrastructures, a collection of many different networks from the public switch telephone network to the internet to corporate local area networks linking work groups, department, or office floor. So as you can see from this figure, a large corporate network infrastructure uses a wide variety of technologies, everything from ordinary telephone service and corporate data networks to internet service, wireless internet and cell phones, and so on. One of the major problems facing corporations today is how to integrate all the different communication networks and channels into a coherent system that enables information to flow from one part of the corporation to another and from one system to another. As more and more communication networks become digital and based on internet technologies, it will become easier to integrate them. Next, key digital networking technology. We have client server computing, packet switching, TCP, IP, and connectivity. First, client-server computing is a distributed computer model in which some of the processing power is located within small, inexpensive client computers and reside literally on desktop, laptops, or handheld device. So, as we can observe in a diagram, so from client's request to internet to server, then the server have a response to internet to clients. The server sets the rule of communication for the networks and provide every client with an address so others can find it on the network. Next is packet switching. In a packet switch networks, messages are first broken down into a small fixed bundle of data called packets. The packets include information for directing the packet to the right address and for checking transmission errors along with the data. Next is TCP, IP, and connectivity. A protocol is a set of rules and procedures governing transmission of information between two points in networks. As we can observe in the diagram, PC is saying hi to another PC and PC is saying have a response which is hello. So the every PC have different internet protocol. So TCP refers to the transmission control protocol which handles the movement of data between computers. So TCP established a connection between the computers, sequence the transfer of packets, and acknowledge the packet sent. So IP refers to Internet Protocol, which is responsible for the delivery of packets and includes the disassembling and reassembling of packets during transmission. Then Communication networks. So let's more closely at alternative networking technology available to business. Next is signal. So signal, digital versus analog. So what is the difference between the two? A digital signal is a discrete binary waveform rather than a continuous waveforms. Digital signals communicate information as string of two discrete states, 1 bit and 0 bits, which are represented as on-off electrical pulse. Computer uses digital signals and require a modem to convert these digital signals into analog signals that can be sent over to telephone lines, cable lines, or wireless modem to analog signals. Then analog signal is represented by continuous waveform that passes through a communication medium and has been used for voice communication. The most common analog devices are the telephone handset, the speaker on your computer, or the iPad earphone, all which create analog waveforms that you ear can hear that your ear can hear. So next is modem. Stands for modulator demodulator. Cable modems connects your computer to the internet using a cable network. DSL modems connect your computer to the internet using telephone company's landline network. Wireless modem performs the same function as traditional modems, connecting your computers to a wireless networks that could be a cell phone network or a Wi-Fi network. Functions of modem. A modem is a device that translates digital signals into analog form and vice versa. So the computers can transmit data over analog networks such as telephone and cable networks. So types of computer networks. So we have local area networks or LAN. So up to 500 meters, half a mile of an office of building, and campus area networks or CAN, which is up to 1000 meters, a mile, or a college campus or corporate facility. So what is a LAN? The LAN uses a compute client-server architecture where the network operating system resides primarily on a single file server, and the server provides much of control and resource for the networks. Alternatively, LANs may use a peer-to-peer architecture. A peer-to-peer network treats all processors equally and issued and used primarily in a small networks with 10 or fewer users. The various computers in the network can exchange data by direct access and can share peripheral device without going through a separate server. The LAN using the Windows Server primarily of operating system. The peer-to-peer architecture is called workgroup network model, in which a small group of computers can share resources such as files, folders, and printers over the network without dedicated server. So the Windows Domain Network model, in contrast, uses a dedicated server to manage computers in the networks. Larger LANs have many clients and multiple servers with separate server for specific services such as storing and managing files and database. So metropolitan area networks or MAN or a city or metropolitan area. Once wide area network span broad geographically distance entire regions, states, continents, or the entire globe. The most universal and powerful one is the internet. Computers connect to a WAN through public networks such as telephone system, private cable system, and through leased line or satellite. Its geographically scope fall between a WAN and LAN. Next is transmission media and transmission speed. Networks use different kinds of physical transmission media, including twisted pair wire, coaxial cable, fiber optics, and media for wireless transmission. Each has an advantage and limitation. A wide range of speed is possible for any given medium depending on the software and hardware configuration. Bandwidth transmission speed. The total amount of digital information that can be transmitted through any telecommunication medium is measured in bits per second or bps. One change or cycle is required to transmit one or several bits. Therefore, the transmission capacity of each type of telecommunication medium is a function of its frequency. So, you can see and about below. So, as the internet evolved, our our internet also evolved faster and uh, so from 1G to 5G. Next is physical transmission media. So we have twisted pair, stands for copper wire twisted in pairs for voice and data communication. Speed 10 megabits per second to 1 gigabits per second. Next is coaxial cable, thickly insulated copper wire which is capable of high-speed data transmission and less subject to interference than twisted wire, currently used for cable TV and for network with longer runs more than 100 meters up to 1 gigabits per second. Then a fiber optic cable stand for a clear glass fiber transmitting data of pulse of light generated by a laser, useful for high-speed transmission of large quantities of data, more expensive than other physical transmission media and harder to install. Often used for a network backbone, so up to 500 kilobits per second to 6 trilobits per second. Then wireless transmission media based on radio signals of various frequency and includes both terrestrial and satellite microwave system and cellular networks used for a long distance wireless communication and internet access up to 600 plus megabits per second. So thank you. That's all for my report.